NASA's alert system just detected something so advanced it can reach light speed. For decades, Albert Einstein's theory of relativity has formed one of the core foundations of physics and has been very instrumental in the understanding of the secrets of the universe, which still remains largely elusive and much more complex than we can ever imagine. According to this theory, the speed of light, a constant 299,792,458 meters per second, stands as the universal speed limit, as nothing has been proven to exceed this. But in the unending quest to unlock and harness the vast potentials of the universe, there's been some intriguing theories which today are very popular in theoretical physics, being brought forward as possible ways we can break that limit and travel through space. From the theorization of wormholes to the speculation of Tier 3 civilization, these theories open up a pathway for a glimpse into the possibilities of faster-than-light travel. Number 5. The wormhole. Theorized by Albert Einstein and Nathan Rawson in 1935, wormholes are hypothetical tunnels through spacetime, linking two distances that are otherwise stretched far apart. They would allow you to travel from one point in the universe to another much faster than the speed of light. Supported by Einstein's theory of general relativity, the theory of gravity developed by Albert Einstein portrays gravity as not being exactly a force. Instead, it's been described as a warp in spacetime. And so, spacetime can be curved by the presence of matter and energy. Wormholes arise as solutions to Einstein's field equations, allowing for the possibility of creating a shortcut or tunnel through spacetime. Let's say we were able to create a wormhole. It could potentially provide a means for faster-than-light travel or shortcuts across vast cosmic distances. This works with the idea that one end of the wormhole would be located near the starting point, and the other end would be located at the destination. By passing through the wormhole, one could theoretically reach the destination faster than if they had traveled through regular spacetime, which could have involved traveling across a whole stretch of surfaces. But there's major shortcomings with this theory. Wormholes are understood to be very unstable, and what would likely happen is that they will likely collapse as soon as they tried to use them. This is because creating and keeping a wormhole open would require an enormous amount of negative energy and exotic matter, which to this day remains very much theoretical. Tachyon. Tachyons are hypothetical particles with the potential to travel faster than the speed of light ahead of any subliminal particles. They've never been observed and will involve creating a situation where time moves in reverse. Tachyons would have some strange properties. For example, if you were to fire a tachyon gun, the bullet would appear to come out of the gun before you fired it, distorting the concept of casualty as we know it, and will raise questions on the consistency of cause and effect. The mass squared for tachyons would be negative, meaning that one of the major properties will be the possession of an imaginary mass. This peculiar characteristic is a consequence of the Lorentz transformations, which describes how quantities such as mass, length, and time change as an object approaches the speed of light. When a subluminal particle travels faster than the velocity of light in a medium, it emits Cherenkov radiation. In a like manner, if a particle like tachyons exists and travels through a medium, the expectation is that they will emit a peculiar form of radiation known as tachyonic Cherenkov radiation. Furthermore, tachyons are incompatible with our current understanding of fundamental physics, such as Einstein's theory of relativity. Special relativity prohibits subluminal particles from being accelerated to or beyond the speed of light, as the resultant effect may be very severe. Number 3. Warp drives. Made popular in science fictions like Star Wars, warp drive is a highly speculative concept that's been explored as a potential means for realizing faster-than-light travel in theoretical physics. Also known as an Alcubierre drive, as proposed by Miguel Alcubierre in 1994, warp drive involves manipulating the fabric of space-time itself to achieve faster-than-light travel. Instead of moving through space, The idea is to create a warp bubble around a spacecraft that contracts space-time in front of the spacecraft and expands it in the rear, creating a region of space-time that will potentially move faster than the speed of light. The theoretical calculations for the Alcubierre drive require the existence of exotic matter with negative energy density. This form of matter is purely speculative and has not been observed or created in any practical sense. The nature and properties of the exotic matter remain largely unknown and not yet something that modern physics can account for. The energy requirements for a warp drive are believed to be very much enormous. The calculations suggest that the amount of negative energy required to create and sustain a warp bubble would be equivalent to the mass energy of the entire planet Jupiter. The ability to harness and manipulate such vast amounts of energy is far beyond our current technological capabilities. The Alcubierre metric solution raises concern about the stability and control of the warp bubble. The original proposal indicated potential instabilities, issues with directing the bubble, and the release of high-energy particles upon arrival at the destination. These challenges would need to be addressed for a practical warp drive to be feasible. Number 2. Quantum entanglement. Quantum entanglement is a phenomenon in quantum mechanics where a couple or more particles become correlated in such a way that the state of one particle is instantly connected to the state of the other, not minding the distance between them. While we can see this as a fascinating and well-established concept in physics, it does not provide any realistic means for faster-than-light travel or communication. The link between entangled particles is often referred to as spooky action at a distance, as changes in the state of one particle are observed to have an automatic effect on the other particle, no matter the distance between them. However, this instant correlation does not violate the principles of special relativity, so the particles remain subluminal. Quantum entanglement is highly unsuitable for transmitting information faster than the speed of light because the correlations between entangled particles are random and cannot be controlled or manipulated to convey a predetermined message. Some alteration happens along the line. Even if a change is observed in one particle, the information that change represents cannot be used to communicate or transmit information to a distant location faster than the speed of light. Attempts to exploit quantum entanglement for faster-than-light communication, known as quantum non-local communication, have been rigorously studied and classified as no communication theorem, which states that it is impossible to use quantum entanglement to transmit information faster than the speed of light without violating fundamental principles of quantum mechanics. As quantum entanglement is a remarkable and puzzling phenomenon, it does not offer a practical means for faster-than-light travel or communication. Its significance lies in its implications for our understanding of quantum mechanics, quantum information, and the fundamental nature of reality, rather than its potential for achieving superluminal travel or communications. Advanced civilizations. Russian astrophysicist Nikolai Kardashev proposed a scale in 1964 that classified civilizations into 3 types: planetary, stellar, and galactic civilizations. The first tier, which is planetary, references a civilization able to harness all the resources they have available on a planet. The second tier, stellar, looks at a civilization with the ability to capture and use energy from the stars, while the last talks about a civilization able to harness the complete energy from whole galaxies. The idea is that having all the energy available for use can make faster-than-light travel possible. However, based on our current understanding of physics, specifically the theory of relativity, exceeding the speed of light is not considered possible for any object with mass. According to Einstein's theory of special relativity, as an object with mass accelerates, its energy increases, and its mass approaches infinity as it approaches the speed of light. This would require an infinite amount of energy to propel the object to the speed of light, making it impossible to achieve. Moreover, as an object with mass approaches the speed of light, its relativistic mass increases, causing time dilation, length contraction, and other effects. These relativistic effects make it increasingly difficult to accelerate the object further, and they become infinite as the speed of light is approached. Therefore, based on our current understanding of physics, it's not feasible for any object with mass, including a spacecraft, to exceed the speed of light. This limitation is a fundamental part of our understanding of the universe and is supported by a wealth of experimental evidence. However, it's worth noting that the realm of theoretical physics is constantly evolving, and new insights and discoveries may emerge in the future that challenge our current understanding. And maybe someday, we will be able to have a different discussion on this topic. Speculative concepts such as wormholes, warp drives, or other yet-to-be-imagined breakthroughs may provide alternative possibilities for achieving faster-than-light travel. But at present, they remain purely theoretical and have not been demonstrated or realized in any practical sense.